Okay, in this video, I will be talking about Newton's third law of motion. First, we can see a basic introduction about this law. According to Newton, when bodies interact, they exert a force on each other. This, this is the main basis for Newton's third law. Now, these forces are known as action and reaction forces. Newton's third law of motion explains that force always comes in action-reaction pairs. That is, if two bodies are interacting, then each of them will exert a force between them. For example, if two bodies A and B are in contact, then A exerts a force of FAB on the body B, and similarly the body B exerts a force FBA on A. Identifying and describing these action-reaction force pairs is a simple matter of identifying the two interacting objects and making the statements, that is, who is pushing on whom. That is what is considered what direction. Now let's see the basic statement for Newton's third law of motion. Newton's third law of motion states that for every action, there is an equal and opposite reaction. As already told, that is, the two bodies that I have told earlier, that is a body A and B, and the forces which are interacting between them is FAB, which is the force exerted by A and B, and FBA is the force exerted by B on A. According to Newton's third law of motion, FAB is equal to minus FBA, which means the force exerted between these two bodies will be equal and opposite in direction. Now we can see some examples of this Newton's third law of motion. That is, we can see some action-reaction pairs. Okay, in this figure is shown a balloon which is rising up. Firstly, the balloon is filled with air. Then the air is let out. On letting out, the air pushes downward, which is the action, which results in the balloon rising upwards, which is the reaction. Now we can see another example. In this, a gun is firing a bullet. When the gun fires the bullet, it causes the gun to move upwards. That is, the gun drives the bullet forward while the bullet exerts a force which drives the gun upward, which is the reaction. Now we can talk about law of conservation of momentum. This is a major consequence of the Newton's third law of motion. And it states that when two or more bodies acts upon each other, their total momentum remains constant, provided no external forces are acting. So, in short, we can say that momentum is never created or destroyed. This law of conservation of momentum is proved in the next slide. We can see how it is proved by considering the Newton's third law as well as Newton's second law. Now conservation of momentum proof. Consider two balls A and B of masses ma and mb respectively. Each are having an initial velocity of A is having an initial velocity of ua while B is having an initial velocity of ub. Consider ua greater than ub. Hence after a time t, both the balls collide. When both these balls collide with each other, the ball A exerts a force FAB on B, and similarly B exerts a backward force FBA. So we can see the change in momentum of the ball. The initial momentum of the ball before collision was ma into ua, while after collision it was ma into va, where va is the final velocity. And hence change in momentum of the ball A is equal to ma into va minus ua divided by t. Similarly, the change in momentum for ball B is equal to mb into vb minus ub divided by t for a time t. Now, we have already seen that by Newton's third law of motion, in case of two bodies interacting with each other, that is, in the case of an action-reaction pair, the forces between them are equal and opposite. Hence, we can say that FAB is equal to minus FBA, or MA into VA minus UA divided by T is equal to MB into VB minus UB divided by T, which gives, on rearranging, gives MA into UA plus MB into UB is equal to MA into VA plus MB into VB. In this case, the left hand side is the total momentum before collision, while the right hand side is the total momentum after collision. Hence, it is proved that the total momentum doesn't vary after a collision, and hence we can say that it is conserved. Thus, the law of conservation of momentum is proved. Thus, we come to the end of this video. We have discussed some basic concepts about Newton's third law of motion as well as its applications and the law of conservation of momentum. If you have got any doubts about any of these topics, feel free to comment in the section below this video. Thank you.